Good afternoon, everyone. I think we'll give it a couple of minutes as the numbers keep going up, but we'll start in a couple of minutes. Alrighty, well, we've got a pretty packed hour plan, so I think we're gonna start going. Welcome everyone to the Vention and Tulip workshop on Agile manufacturing. The topic for today that we're focusing on is staying flexible and adjusting production. As everyone knows, a lot of factories and warehouses have had to retool their operations in order to accommodate unforeseen circumstances. So today we have with us Patrick Ald, who's the Chief Business Development Officer at Vention, and Saul Lusgarten, sorry if I botched that, Head of Product Management at Tulip. So to give you a bit of a glimpse in what we're going to cover today, we're going to zoom out a little bit and take a look at the state of the industry. So where are we now? How did we get here? And where are things headed? We'll hand it off to Vention, who will take a look at how technologies are democratizing access to automation. We'll zoom in a little bit into the actual frontline workforce, where Saul will take us through technologies that are empowering the frontline. And then we'll take a walk through a live case study that both Vention and Tulip completed together. So without further ado, I'll hand it off to Saul.
Thanks, Jennifer. Hi, everyone. It's great to be here. It's great to be here with Patrick, with Vention. Thank you for joining us. I know we have people from all over the world. I hope you're all safe and well. I guess as Jennifer was saying, the talk today is about how manufacturing companies can stay flexible and nimble. Lean manufacturing was the original response to this question, but agile manufacturing goes a bit beyond. It goes a step beyond. It describes really organizations that have created processes, tools, and training to enable them to quickly respond to customer and market changes much more faster than they otherwise would. Last year, we hosted with Vention and a number of other companies the first Agile Manufacturing Summit to go over some ways in which new technologies were enabling Agile manufacturing. While new technologies might be the enablers, I think the drivers are changing conditions in their environment, and companies need to do faster new product introduction. Customers are changing what they demand for much faster than before. Companies are dealing with global supply chains, so the complexity really calls for more agility, and companies that are able to do that really have a competitive advantage. So I guess since we're in the middle of a global crisis with COVID-19, I think this is worth using as a timely example of how agile manufacturing works in action. So if we go to the next slide, we can think about, times of crisis in general bring good, extraordinary feats. One of my favorite examples during the Second World War was the Kaiser shipyard. They were able to build entire ships in 4 days, when before the war, that process usually took 45 days. So in general, when there's a crisis, you see how companies are able to move faster and do things a bit differently. And I think COVID-19 obviously is no exception. We're seeing amazing scales ups of production, right? I think in China, for example, they increased production 20x to over 200 face masks a day in a matter of weeks. And we're seeing similar things in the West, in other countries. And we're also seeing shifts in production. So companies like automotive companies who usually don't make ventilators or PPE are completely changing what they produce very, very fast in order to respond to these changes in the environment. But agility doesn't only affect production, it also affects how the company itself operates, right? So we also see that with companies moving very fast to ensure worker safety and deploying new technologies and new processes in order to ensure that workers can work in production safely. So I think that the bottom line with all these examples is that the successful companies really leverage new technologies to enable this fast and agile response to the market. In our case, for example, we're seeing companies leverage manufacturing apps to augment their workers on the spot, to retrain them in order to make ventilators, either because they're new hires or they're bringing them from other parts of the company. We're seeing the same with PPE and with other production processes as well. But in addition to this worker augmentation, obviously automation plays a big role. But automation has its own set of unique challenges, as we'll see next.
Yeah, thank you, Saul, and hi, everybody. Very happy to be here. I fully agree with what Saul just mentioned, and I'll continue by taking a point of view of manufacturing company segmentation. Achieving agility and flexibility through automation is especially difficult for the high-mix, low-volume manufacturers. We've all seen automotive production lines that are fully automated with dozens of large industrial robots in a single line. Yet the vast majority of manufacturing today has little to no automation. For small and medium-sized businesses that have to account for variable production schedule to produce a varied basket of products, it's nearly impossible for them to make automating profitable using today's technology. The example we have here is that of a roughly $100,000 automated machine where typically 50 to 60% is comprised of hardware costs and 40 to 50% are service fees that include designing, programming, assembling, and commissioning. Now, if that machine produces less than a certain volume of units in a year, in this case about 20,000, it's almost impossible to have a payback that will justify the upfront investment for that company. So the solutions we discussed today with Vention and Tulip are here to provide solutions for these manufacturers. By simplifying the design to commissioning flow for automated equipment and simplifying the manual assembly steps that remain, these manufacturers in high-mix, low-volume environments can reach the productivity levels that were previously reserved to large industries. Now, I want to double-click on the white rectangle that we see here and talk about why the current technology makes it so difficult to create machines in these environments. Today, creating custom machines is a highly manual process that can take from 2 to 4 months and sometimes even longer than that. The majority of tools available to engineers throughout the value chain were designed for the low-mix, high-volume industries. For example, a 3D design tool allows to design any custom part from or use any part from any manufacturers. PLCs, motors, and sensors can be found in an infinite variety of flavors in terms of size and specifications. Therefore, the process is very manual and time-consuming, and this is what we outline over here. An engineer must start by identifying the specific parts needed from a number of manufacturers and then download the 3D models from their respective websites. Once the main components are assembled in a 3D environment, typically some custom parts are needed to interface between these main components, and those must be designed from scratch. The engineer must then generate a bill of material and all the necessary documentation before transferring the request over to procurement, which will then request some quotes from several vendors, aggregate them, and eventually make a purchase decision. Then one must wait for all the parts to arrive on the shop floor and proceed to assembly and commissioning. In contrast to a more agile and flexible approach, this is more reminiscent of the waterfall development, to take a software analogy, in that it structurally drives cost and lead time in an uncertain environment. In other words, the process today to implement new bespoke machines on the shop floor is rigid, costly, and resource intensive.
Yeah, and to add to that, we see the same kind of waterfall model in IT systems as well, right? In general, manufacturing systems are very much top-down, which drives, the cost up. It makes them harder to implement and slower to do so. And if you add to this, the complexity of manufacturing today, where, as we said before, you have global supply chains, ever more demanding customers, and environments that change very fast, that traditional tech stack that moves in a top-down way is not well suited to respond quickly to that change and to be agile, right? It's by definition rigid and slower to change. So the paradox is that the companies that are able to crack it and are able to, escape it can really differentiate themselves because they're able to be more agile in how they respond to changes in the market. Fortunately, there's digital tools that are helping with this, right? And I think, every time we talk about this, I think it's helpful to remember that this is not the first time that digital tools help an industry change and become more agile, right? Even within manufacturing, if you think of other areas of your operations outside of production, they've already been impacted by digital tools. So, I think about ERPs, when they were introduced, they helped finance move more nimbly. And if you think about more recent developments in computer-aided design, CAD software, and additive manufacturing, they're helping the R&D process move faster. But the production floor, the shop floor, has really been, in a way, left behind by these tools. But there's a new suite of tools, some of which we'll cover today, that are really helping change that equation by letting manufacturers move faster in the shop floor. And I think, with that, I'll hand it to Patrick to cover how Vention helps with that.
Thanks, Saul. And before I deep dive into the tool, I want to talk about trends relating to the automation of the shop floor. And I believe we must think about these in two different categories that all have an effect on the democratization of automation technologies. And this is really the context in which the tool itself lives. The top part here are the longer term, more broader trends, and we'll talk about them. But on the bottom here are what I call the new normal trends that are arising from the COVID-19 situation, which we cannot ignore at this moment. To start from the top, I think pressure on shorter product life cycles. The consumer products may be under the most pressure, but that pressure also applies across all industries. Shorter life cycles means less time for a product to generate revenues, which in turn means that the factory equipment must have a more interesting payback period to justify the investment. Now, there's also acceleration of factory automation. Most manufacturers of plant equipment are moving towards a simplification of products. In other words, the consumerization of industrial technologies. And that is in turn opening the doors for automation in new segments of manufacturing that, as Saul mentioned, have been left behind in the past. And third, the third point here highlights how the ease of use is paramount. Arguably, factory automation technology today is where the personal computing industry was in the late 80s. Its consumerization is opening up the possibilities for a large number of non-experts to be empowered to create and run automated machines, particularly through code-free programming, and we'll give some examples of that in a second. In terms of the new normal trends, I think first one is robots don't catch viruses, at least not the coronavirus type. And in recent history, most manufacturers have optimized for efficiency of their production rather than resilience, and that will probably change in the future. The long-lasting effects of social distancing suggest there will be a strong tailwind for factory automation. Now, if you're like me, working from home has changed our habits. In my opinion, it's redefining the baseline of what employees will expect from their interactions with suppliers, customers, colleagues, and other stakeholders. In other words, cloud-based solutions for collaborating at a distance, like the platform we're on now, and the contactless B2B and B2C e-commerce experiences are likely to become the norm rather than the exception. And finally, I believe manufacturers are more open than ever today to new solutions. This webinar, with its strong attendance, is perhaps a great example of how manufacturers are now taking the time to consider innovative solutions to deal with this new normal. So, taking into account these trends, we can now look at the value chain for Vention users with a new eye. We'll just move on to the next page. The process starts for Vention with our online design tool called Machine Builder. It's a simplified CAD environment loaded with over 600 parts and components for automation. These components are modular, and the software understands how the components can connect together to create automated equipment. This makes the process design faster and easier. Now, as a user designs, the price is available in real time, as well as the assembly time and the parts availability, giving them unparalleled transparency in the process compared to today. The user can then program and simulate this machine directly from the web browser. The programming environment we provide allows users in a code-free environment, and it can be deployed directly on the machine once it is purchased. The procurement is also done online through credit card or corporate accounts and can be delivered as fast as the next day. And finally, users can assemble their equipment just like you would in IKEA furniture, essentially, or use one of our certified system integrators to assist in the commissioning process if necessary. Now, we have some customers that complete this process in as fast as 3 days. The first day for designing and simulating, the second day for procurement and shipping, and the third day for assembly and commissioning. Some will take a few days or weeks, but when contrasting to the traditional approach to machine design, it's a different quantum of time to achieve comparable results. Now, some of you may ask, so what exactly can you build with Vention? So we put here several pictures that are examples of equipment that have been deployed at some clients. The machines are unique and purpose-built for each manufacturer, as each manufacturer has a different product and therefore needs different machines. So on the top in the middle, we see some Tulip workstations. On the top right is an example of an inspection jig for an electric vehicle manufacturer. And on the bottom in the middle is an assembly station for a solar panel manufacturer. All in all, today about 3,000 such machines have been installed in the last 3 years or so. Now, I'll continue on and share my screen just to show a little bit what the flow looks like from a user standpoint. So I believe now you're able to see the Vention homepage. This is where most users will start, and we'll go through the different navigation options. Most people will start with the public designs or the design library. This is over 1,000 examples of machines that have been designed and created within Vention, and that helps as a starting point to determine what machine is going to be needed. So if I was to look for a Tulip workstation, I can simply search through 10 or 12 or 9 at this point assembly stations specifically created for Tulip. Now, I've selected this one over here, the Tulip workstation with conveyor. And what I did just earlier today is open this in our 3D environment and start customizing it. You'll see what I did is I added a gravity conveyor where essentially the use case for this machine is for a user to make an assembly, fill a box, and once a certain number of boxes are created, it is able to proceed on to the next step in this line. Now, I'll complete very quickly what I haven't had time to finish, where essentially I can add several rollers that were missing at the end here. As you can see, it's a snapping process that is very quick to do. And I can also add some bracing that I have here, resizing my extrusions as needed, and using the part suggestion on the top left here to find out what next part is going to be needed. This is based on some algorithms that we've created over time. Now, the last thing is I will open this in what we call machine logic. This is our code-free environment to program our machines. And essentially what I've created over here is a simple sequence to move the gate that we have on this design whenever the user requests to do that. And once I've done this, I can simply hit play and have the simulation in real time. And the operators have access to that environment as well so that they can adjust to the situation as needed. The other thing that I think Saul will cover a little bit later is that this automation in and of itself can be triggered directly from the Tulip station. Now, hopefully this short presentation showed you how some of the trends are impacting the automation industry and how Vention empowers its users on the road to democratizing the automation technologies. And on that, I'll hand it off back to Saul.
Thanks, Patrick. That was very, very interesting, and we'll go over some of it on our side as well. I think when we think about this, we usually think about, I visited hundreds of factories and we talked to hundreds of manufacturers, and one thing we've realized is that no shop floor is the same, even within the same company. Even within the same industry or the same company, no two shop floors will look the same on a given day because the challenges are different. So what we built Tulip for is for really enabling those frontline workers to address the challenges that they have on their shop floor by building what we call manufacturing apps. So if you go to the next slide, you'll see some examples of the manufacturing apps that people can build using Tulip's no-code platform. And the key here is that by building apps to address those shop floor challenges, they're able to improve much faster than they otherwise would. So if we go to the next slide, you'll see how, by turning shop floor processes into an app, you're able to collect real-time data, and that real-time data lets you identify improvement opportunities much faster than you otherwise would because you're seeing it happen in real time. And that data can be used to improve. And that's, that positive feedback loop lets you improve your process much faster than you otherwise would. Now, the key on these apps is that the end user, the person closer to production, is the one building the apps. And the key here is that it's a no-code platform. That means that you don't need to be a developer in order to build apps. You don't need to know how to, connect Internet of Things devices to your apps in order to leverage the industrial Internet of Things. You just drag and drop the different elements of your app as the little video that is showing in order to build those applications that you can use then to run your operations. And some people build them from scratch, but you can also choose from a growing app library that we have where you can choose apps to run on your shop floor and customize. So we see users doing both, either building from scratch or customizing them. But the point there is that you don't need to be an expert to do it. You don't need to be an expert in IoT or in developing in order to build these apps. And the benefit of this is that as you see ways to improve the apps, and as you see ways to improve those systems, and as your production changes, you can quickly change your apps as well to keep pace with production. And the next slide, that's what it covers, is that by embracing this, bottom-up approach to digital transformation and agility, you're able to change much faster than you otherwise would with tools like Tulip. So I'll give a couple of actual use case examples of some examples of apps that people build, very common use cases. So a very common use case is an app to guide complex assembly. We had a customer in the medical device industry. They used an app to guide an operator through the prep to ship process. So back to your point on build to order, Patrick, and how high mix, low volumes environment are challenging. This app guides operators through that process and helps them fulfill over 1 billion product combinations. So no product they fulfill is the same. And with the apps guiding them and augmenting them, they're able to do this without making any mistakes. You also have customers building apps to digitize, production visibility. So instead of using whiteboards, they're using apps to track what happens in production and making this available in real time, both from the machines, by connecting directly with the machines, as you can see there, but also by tracking what different processes and different persons in the shop floor are doing. They're able to have a real-time view of that production. And, the same with defect tracking. So manufacturing, the apparel industry deployed an app to do quality checks. And with this, they were able to do 96% less rework. And they reduce their scrap as well. And the use cases just keep adding, because basically anything you can think of can be turned into an app and digitized that way. So I can show quickly how the platform looks, just to give folks an idea. Let me share my screen real quick. All right, can you see my screen? All right, perfect. So this is Tulip's website. If you go to our site, again, you can try it for free. We have a free trial. And we have some examples of apps that people have built on top of Tulip. There's the app library I was mentioning before. So you don't have to start from scratch, and you can see some ideas of what other people have built and are using Tulip for. But once you go into your account, you'll see, the first thing you'll see is a dashboard. This is customized by you. We see customers build a dashboard for their quality team, a dashboard for operators, a dashboard for production. You really customize the dashboard any way you want. And the different reports you see here are also customizable. So you can build them quite easily by selecting the type of visualizations you want to do, what data you want to use, and so on. And some of the types of dashboards that our customers build are things like, continuous time studies, where you can see every step of a process and you can see how different workers are performing next to your targets. You can do Pareto for defects or for quality issues. And again, it all depends on how you want to be, tracking your production. But this data is coming from the apps that people build. And those apps, I'll show you a very simple example of a work instruction app to guide assembly of a process. So the app this is the app builder, what you're seeing, but what the operator would see as Patrick showed before, is what you see in this screen. So they would start the process, they would scan for a work order, and then the app would guide them through the assembly of that work order. So it can pull from your existing systems, like if you have an ERP, it can pull from there the work order information. It could pull from there your bill of materials. If you don't have an existing system, customers build that on top of Tulip as well. And you can, doing this, you can guide your operations as they assemble the different products. And Patrick was referring to the connectivity between Tulip and Vention, and I'll show an example of how Tulip connects with IoT in general. This process starts with a barcode scanner. So the way in which the app interacts with the barcode scanner is through what we call triggers. So it's very similar to the machine logic that Patrick showed. What this lets you is, without knowing how to code, it lets you connect to a device. In this case, it's a barcode scanner, but you can select from a device ecosystem, including Vention benches. And when you select the device, you select what you want the application to do. In this case, you're storing the device output as a variable on the order ID table. And what this lets you do is interact with devices, but in general, triggers let you add logic to your apps as you build them. And this lets you add, obviously, more functionality to them. And then on the user interface side, everything is, as I said before, drag and drop. It's really as simple as building a PowerPoint presentation in a way, is how I think about it. And then you have the triggers to really add that logic. And then as people run the apps, you can collect the data as I showed before. So with that, I think it might be good to walk everyone through an example of how how this works from a real customer case study, basically. So the customer basically identified shop floor a challenge that they were having. They identified a need there to use an app to solve it. They came to Tulip, they created a free trial with us, and during the free trial, they built an application for addressing that challenge. It's an application very similar to the one I showed. It's a work instruction to assemble. The application connects with IoT devices. So they were able to build that, and they identified the need to have some of the automation that Vention provides. So they went on the Vention side, and Patrick can walk you through what they did there.
Yeah, and essentially that person then signed up a couple of days later on Vention. It's always free to sign up, and you can have access to the full platform. Now, that person started browsing some of the public designs, like the one we looked at earlier, and picked a different one that we had, but picked one existing bench that needed customization, and started playing around in Machine Builder to adapt it to that specific application. Now, they had several questions as they were designing, and therefore were able to request a design review directly from the CAD environment, and was put in contact with Vention's application engineers, who were able to have a look and put a second pair of eyes on the design to validate that it would respect the laws of physics and that it would work well for their application. A couple of days later, this went through the purchasing process using a credit card, and in a matter of 48 hours in this case, the customer received flat pack boxes, started assembly, and as you can see on the right there, was able to put together the Tulip workstation using only one tool and all of the equipment that was provided by Vention.
Yeah, and in this case, the different IoT devices that they connected, they were able to connect on their own with Tulip through our gateway. And obviously, the devices were working with the app that they had built, and immediately they were able to start running the app on the Vention bench and collect real-time data, as we're showing here. So I think this is a great example of a company leveraging, two sets of tools to move faster and to really deploy a new line essentially in their shop floor very, very, very fast, and address the challenges that they were having without having to wait the traditional months in order to build this from the ground up.
Yeah, I believe, Saul, this truly highlights the complementarity of both of our solutions in terms of the physical world, but also in the software world, how basically the same principles are put in place to solve complementary problems and provide solutions for our mutual customers.
Agree.
Great. Well, thank you guys for that that presentation. I think you really hit the nail on the head in that what we're seeing here is two complementary solutions that are enabling manufacturers with that agility. That's particularly important in any day circumstances, but specifically in unknown circumstances like where we are today. So thank you very much for that presentation. And throughout it, we have actually been collecting quite a few questions. So bear with me as I try to sort through and create little buckets here because we have a few similarities. But the first question we have, and again, a reminder to please continue submitting questions as we go through. The first one I think we have is, do you feel technologies like Vention and Tulip will help address the skills gap, or do you feel that they're creating an even larger skills gap? Interesting.
Interesting. So I guess maybe I'll define the skills gap in case, I mean, the way it usually gets used, the skills gap is this notion based on data that there's going to be a shortage of I think 2.4 million jobs of people who don't have the skills necessary to use new technologies on the shop floor. I think it actually, it doesn't increase it. I think it can help decrease it because both Vention and Tulip are what you could call no code, no integration type of solution. So you can take someone who doesn't know how to, write software and use Tulip to build apps to deploy on their shop floor. So actually, whereas before you had to learn programming from scratch and you had to, become an expert on that, with tools like this, you can actually achieve the same end result without that technical knowledge. So I think it can actually augment workers to be able to build those applications, but also the end users of the applications can then be trained on the spot. And we see this all the time with our customers. They're trained on the spot on new processes with these apps. So I think it can actually augment your workers instead of replacing them. Yeah.
I agree with that. I think it truly empowers the person who is feeling the pain point of little automation or very varied work instructions, and putting the tools in their hands so that they're able to actually address that systematically. So I agree with you, Saul. I think it's actually lowering that barrier.
Very good. Thank you. Do you feel that the manufacturing industry, and I think it actually plays well off of the previous question, is do you feel that the manufacturing industry is ready for these end-to-end solutions that almost require that open compatibility between companies?
I believe so. I think now more than ever, the manufacturers are looking for e-commerce, online experiences from their B2B vendors. The end-to-end solutions are the way to reduce the time and cost associated with implementing these type of industrial designed automation projects. And same thing for Tulip in terms of empowering the worker. I think these end-to-end solutions will continue to become more prevalent in the future.
Very good. I had one almost component-specific question. So we did talk about how our applications from both sides of the spectrum apply to different industries. So one attendee would like to know if we have clean room compatible components. So this is, I guess, more tailored towards the medical side.
Maybe I'll start with this one. So we have some components that can go in the clean rooms. Now, depending on the level of certification of that given clean room, you may need to take that equipment and make sure that it is certified for the location that you're going to use it with and the level of clean room that you're using. And we can provide things like zinc-plated screws or different types of greases if necessary, so that it is compliant to that clean room. So I think it's a very specific question, but we've tackled that question in the past on our end.
On our end, I guess it's not as specific to components, but we do see customers using this type of applications in clean room environments and highly regulated environments. So in life sciences and med device, we have, for example, people using apps they've developed to do electronic logbooks or line clearance. So I think that there's an opportunity there as well to make sure that those operations can be agile as well.
Thank you. So I think this question is geared towards you. Marco would like to understand if the stations come with out-of-the-box databases.
Yeah, so Tulip, the Tulip apps, if you're using an app that already exists, what we call an app bundle,
Are you there?
A table works kind of like an Excel spreadsheet. So imagine your SQL table, but you don't need to know how to code in order to use them. So if you were using a bundle, so an app that already exists in Tulip's app library, it would come with a table. Otherwise, you can add it to the apps yourself. As I said, it's pretty easy. You can have multiple tables per apps. You can have the same table across multiple apps. It's pretty flexible, just like SQL would be if you were developing this outside of Tulip.
Okay. Thank you. We're getting quite a few questions about, again, building off of the previous one, whether different components are available for different environments. So I think that might be a good opportunity as a follow-up just to address all of them. I think maybe as one follow-up question again to Salisari is how Tulip kind of positions itself within the MES environment. I know this is something that you had actually previously posted about, so maybe that's something you'd like to shed light on, Sal, again.
Yeah, sure. So MES, for those who don't know, it's a manufacturing execution system. So it really means different things to different people and different companies. But traditionally, it's defined by a set number of functionality, different modules that you can use in different parts of your shop floor. Tulip, against an MES, we see two things. We see either companies that are using Tulip to replace an MES, or either because they already have one or because they are going from no MES to Tulip, or they use it to augment their MES. So the thing about MES is that they're very powerful and robust, but because of that, they're quite rigid and inflexible. So back to the point before, at the beginning of this webinar, we were talking about how traditional IT systems in manufacturing are rigid and take a long time to implement. So in MESs, on average, can take up to 18 months to scope the implementation. So this is like very lengthy process. That's expensive. A lot of manufacturers can't afford that in terms of cost or in terms of the opportunity cost to deploy that. So with Tulip, you can start getting value much more faster because our approach is not a rip all and replace. It's more like you start with a single app on a single place. Once you see value, you can replicate that app or add more applications around your shop floor. So, again, you can either see it as an augmentation of your MES if you have one, or you can see it as an alternative to MES if you don't have it, because you could build the same type of functionality, but again, in a very different way, because it's more flexible, it's more agile, really.
Great. I have an interesting question here from Jessica. She says that both of you reference modularity in your solution, but could you provide examples of how either of your solutions have been repurposed to address more than one, whether it be case study or case study, yeah?
Mm-hmm. Sure, I can start on that one. We've had customers that started with a single, simply structural station, much like the one that we discussed earlier, that leveraged the Tulip environment as well. And that person and that client simply built off of that first workstation. So they started with the workstation, eventually added conveyors around them, then some automation components to push and pull the items through the process that was there. And so the original station in another type of environment would not have been able to evolve in that same way. And some of the parts that were not necessary or that became superfluous on version 1 were then reused on version 4 of it. And so the fact that all of the components are optimized to fit together, both in terms of their mechanical properties, as well as from the software side, this really enables somebody to play with their imagination and reuse the same parts that they have over and over again. Yep.
Yeah, that's interesting because I think the same thing happens to us on the software side. So when customers build, either an application or a set of applications that they, that they're building to address a specific use case in their shop floor, you can pretty easily, abstract it, and it becomes something they can apply to either other factories in their company, or that you can actually apply to other companies in the same industry or others. We have, for example, a 5S app to guide the 5S audit. That app was developed originally by a customer who was using it to digitize their 5S audit process. And we quickly started seeing other customers do similar things, and it became, something you can easily replicate from one company to the other in a very modular way as well.
Very good. So, Saul, I have a question from Sanjay here. If the solution is for Tulip is deployed and hosted on the customer service or not?
Yeah, we have both options. By default, it's a cloud solution, and this is kind of what we recommend our customers. We have within cloud, it can be private or gov cloud, depending on what the customer needs. But we also have on-premise for customers in industries like air defense or pharma that can't use cloud solutions because of regulation.
Very good. I think we would have time for one more question, and I have a really good one here that I've kind of been saving. It came in earlier on. Geared towards both of you, do you feel that manufacturers, had they been more openly adopting technologies, they wouldn't have been as affected by COVID-19? It's a loaded question.
It's a good question. I'll let you take that one first, Saul, and then I'll cover it later.
Yeah, I mean, I think thinking that technology could have prevented COVID-19 might be an overstretch, but I do see that manufacturers who have embraced digital technologies have been better prepared to react to this. And we see that across the value chain. And, we have customers all around the world, and we really see that those who have embraced those technologies were better prepared to respond. So from things like safety in the shop floor, we have customers who used, for example, Tulip to build apps for inspection. So when customers were coming, when their workers were coming in, they could see temperature checks and things like that to ensure that if somebody had symptoms, they could be properly isolated and taken care of. And we see the same with other technologies as well. So to ensure worker safety, also to scale up production, to shift production, to address COVID needs. So, and also to enable remote work, the companies that embraced, machine monitoring technologies were able to operate a smaller, smaller overhead, their factory. So I am seeing that. I'm still seeing it, and I think if anything, COVID-19 is showing manufacturers the need to really embrace digital technologies, if not only for this one, but for the next crisis that might arise. So I am seeing an acceleration in the adoption of new technologies.
Yeah, I agree. I think the topic of today's webinar was agility and flexibility, and I think your question, Jen, was would they have been as affected by COVID-19? I think the answer is yes. However, their ability to be able to redeploy more easily and in a rapid way would have been increased. And I think that's the difference. It's that upfront investment in the kind of technologies we're discussing today allow the manufacturers to be prepared to shift on a dime and address what the market needs in the moment, right? And so they would still have been affected, but I think we've seen tremendous efforts from a number of manufacturers to redeploy and repurpose their production line to address the COVID situation. And I think those that are the most prepared and that have invested the most in these technologies are the ones that are able to more rapidly redeploy and therefore be the first one to help in this case.
Very good. Thank you to both of you for answering that question. That was quite loaded. I think that concludes the questions for us for today. Anything that we didn't have time to get to, we of course will follow up in an email and provide more information. Again, I wanted to thank both of you for running us through this presentation. I think there's quite a bit of insightful information and particularly interesting to see how two unique companies come together to provide one seamless solution. So really looking forward to seeing how more case studies evolve in the future. Thank you everyone for joining us, and we'll of course be following up with more information after the webinar. Thank you.
Thank you.
Thank you.
Thank you everyone for joining.